everyone, welcome back to my channel Learn Math with Priya. In this video, we are going to derive the formula for total surface area of a cone, which we call it as TSA, and curved surface area of a cone, which we call it as CSA. So first, what is surface area of a cone? The surface area of a cone is the area which covers the entire surface of a cone. So in order to calculate the total surface area, we need to find the area of two parts. One, the area of a circular base, and two, the area of a curved surface. Area of a circle we know is pi r square. In order to find the area of a curved surface, we are going to look into the GeoGebra. I will give you few tips to use the right formula to solve the problem. Let's get into the video. Before going to derive the formula, let us observe the shape of a cone. So you can see here, from the center of the base to the vertex, we call it as height. And this is at angle 90 degree to the radius. Hence, it is called right cone. So we are going to derive the formula for the right cone. And what is this now? The arrow has been specified, right? This we call it as slant height, which is specified by the letter L. Let's understand it better by unfolding the cone. So when I'm unfolding it, you can see the top layer becomes a circular flat surface. And now I'm going to cut the slant height. Don't misconcept this as a vertical height, H. It is a slant height. Here they represented with the letter S, but we used to represent with the letter L. So I'm just cutting along the slant height and I am opening the cone. So it becomes another flat surface like this. So now we have two flat surface. With this net, we can derive the formula now. So now you understand how the net of a cone has been made. So you can see the two surface given here. One is circle and its area is pi r square. And the other is a blue face, which we call it as curved surface area. So this curved surface area we need to determine by dissecting this into triangles. Let me show using GeoGebra. So let us take this blue shaded part separately. So consider the shaded as a blue face. Now I have to determine the area for this. So we know that the cone, so the right cone with the base as a circle has been opened along the slant height. So this is nothing but the circumference of a circle, which is 2 pi r. Now I am just removing that layer and straightening it. Now, as I said, I am going to dissect this in terms of small triangles. So if I want to make it as 12 parts, it will look like this. Or if I want to cut into many parts, it will look like this. I'm going to rearrange these triangles along the length of the arc. So the length is 2 pi r. So what I'm going to do, I'm taking off of this and just rearranging it to make a rectangle. So the length of the arc become half now, right? Because I have rearranged the triangles to make a rectangle. So this will become 2 pi r by 2. The full length is 2 pi r and half of the length is going to be 2 pi r divided by 2. So now the length of this rectangle becomes pi r and the breadth of this rectangles become L, right? So what is the area of a rectangle? Area of a rectangle is nothing but length times breadth, which is pi r times L, which is pi r L square units. So this is nothing but the curved surface area of a cone, isn't it? Because I have taken this blue face and I just dissected that into triangles and rearranged to make a rectangle. So this is nothing but CSA of a cone, and the formula which we derived is nothing but pi RL square units, isn't it? So now, what about the total surface area? So TSA of a cone is very simple because we already found the CSA of a cone, which is pi RL, and another face is a circle, which is nothing but the area is pi r square. So I'm just adding these two areas, pi r square plus pi rl. Now we have learned factorization, so we are going to take the common factor out. So pi and r. So in this first term, we will have r remaining, and here pi r I have taken commonly outside, so remaining is L. So this is the formula for TAC of a cone, and the unit is going to be square units. So once the radius, slant height, and the height of the cone is given, we can determine CSA and TSA of a cone. Suppose you have to determine the CSA of a cone where you don't know what is the slant height is. So how will you determine slant height, which we are going to see now. Let us consider this right angle triangle, and you know this is nothing but slant height, right? So slant height and the radius and height are related using Pythagoras. So I can see L square. So I can use Pythagoras theorem where L is going to be the hypotenuse side, right? So L square is equal to h square plus r square. So when I take square to the other side, it becomes square root. So L is nothing but root of h square plus r square units. So this is the formula for determining the slant height when the height and the radius is given. So hope you understand how to derive the formula for CSA, TSA and the slant height.